that the having code, then we are going to be encode the data. So this is actually my original data that has been given here. So with that original data, so we have found that what is going to be the 7-bit, I mean having code including the parity bit, right? So we have seen that how we are going to be calculate that the parity bits for the requirements, and we have found these values. So 1001 and 100. So this is my 1001 100. So this is for event parity, and also we have seen for the dot parity. So now we are going to be work with that the event parity. So I have given this and I have asked you to practice this too, that how you are going to be generate that the Hamming code and encoding part. So now here that we are going to be on the receiver side, right? So that the sender has sent it to that the next node. So this is your receiving node where you have got that the encoded message, that the message has been it's sent. So we know that if we are going to be I mean in the receiver side, if it is correctly received, then there is not going to be any error. Okay, there is not going to be any error will be found by the receiver side. So by knowing that, actually we have actually changed one bit from this original encoded message. We have actually changed one bit, so you can see that this is the bit actually you have changed. It was 0, so we have make it 1 with the orange color. I have shown it. So it's saying that 74 Hamming code is received as 1101100. So detect the error and correct the code when even parity is used and decode the data. So by seeing that the data, we have changed the bit numbers. I mean that the bits from 0 to 1. So we can see that actually where is the error is. But let's see that the how the receiver is going to be detect the error. Okay, by applying the Hamming code scheme. So it has been mentioned that yes, detect the error, correct the error when the event parity is used. So we have taken that the event encoded message, event parity encoded message, and after detect and correct, then we are going to be decode the data. So this is that the data that has been received, it has been said. So we are writing this. We know that there are 7 bits. So we said we will go always from left to right. So that's why I written that the position 1 2 3 4 5 6 7. I'm having the 7 bits here, so you can see that it is 0 0 1 1 0 1 1. So 0 0 1 1 0 1 1. So this is that the serial you have written here. So now yes, I mean the receiver side, by applying the same method that what we have seen in the sending side method. So he is going to be know the position of the bits. I mean this is the serial. He is going to be know that for the 7 bits and 4-bit data. So now he is going to be put these values that the received bits. He is going to be put this serially. So you can see that 0 0 0 0 1 1 1 1 0 1 1. So this is that the bits. I mean he has placed it. Now he is going to be checked that the received bits are actually error free, or that is with error. So here to do that, he is going to be use here the 8-bit representations. Um that we have seen in the last class. So receiver side also going to be use this. So you know that this is the P1. Right to again that right to the left side we have moved. So the first one, the first parity is P1 here for the first column, and the second column is P2, and the fourth column is for P4. Third column is for P4. So now here he is going to be apply that. Okay, for if it is that the event parity is been said. So for P1 he is going to be find out that uh, what is going to be the parity bit, I mean for the P1. So now you can see here, if you're looking to that the P1 column, so we say the first one we are not going to be checked because it is the position of that the P1, that the first parity bit. So we are not going to be take the first one. So the later 3 other ones we are getting here, that we are going to be actually take into account. So you can see that one is here in this column, that is in the serial number 3. So this is actually the D3 that we have written here. And the next one is that the one here, and that is the serial number 5. So it is D5. And the last one is here, last one, that is the 7. So D7. So that I have written here. In case of P2, I have said that first one we are not going to be taken because this is the position of that parity bit, second parity bit. So now you can see that here this is the 3, and this is the 6, and this is the 7. So it is going to be D3, D6, D7. So we can see that D3, D6, D7. Now we are looking for that the P4. So if we're looking to the P4, so first one we are not going to be take. This is the position of the third parity. So now you can see that the rest of the ones are here, 5, 6, and 7. So this is the D5, D6, and D7. So now you are going to be put the data that the D3 you are going to be take from this receive bits. So you can see the D3 here is the 1. So you're running here the 1, and D5 is your 0. So you're running 0, and D7 is your 1. So you're adding 1. Okay. And for these D3, D6, D7, so D3 is 1, D6 is 1, D7 is 1. So you're running that 3, 1. And the D5, D6, D7, D5, D6, D7. So it is 0, 1, 1. So you're running 0, 1, 1. So now, as because it is even parity, so you're having, if you're having that the even number of 1, then you're going to be at 0. If it is that the odd number of 1 you find, then it is going to be at 1 to make it even. So that here already we are having that the even number of 1. So that's why we have added here 0. Okay, so so this is that the 0 we have written here. Okay, that we have added 0 for P1. So now that the found parity bit for P1, you are going to be compare it with that the receive parity bit. So that the receive parity bit is the 0. So there's the 0 and 0. So that means it is same. Okay, the found one and the receive bit for parity 1 is 0 and 0. So it's same. So if it is same, it said that if there is no error in the parity bit is going to be 0. So if it is same, that means there is no error. So that's why we are writing that P1 is actually with 0. P1 equals 0. So as because there is no error. When it is going to be error, if that the bits are different, the found bit and that the received bit. If this is different, then it is going to be error. It said that if there is an error in the parity bit is going to be 1. And if there is no error, 0. So there is no error for P1. We can say that it is 0. It is also 0. So that's why we written 0. Now you come for that the P2. So in that the P2, you are having the 3, 1. So that the odd number of ones we are having. So that means we are going to be add 1. So you can see that we have added 1 here. So that is what I have written here 1. So this is the found one for P2, and you have to compare it with that the receive bits P2. The receive bit P2 is 0. So and here now found P2 is that the 1. So that you can see that these are the different values. These are not the same. Okay, so that means there is an error. So the receiver understand. Okay, there is some error is there. So that's why it should need to be 1. So he said that if there is an error in the parity bit is going to be 1. So that's why you have written 1. So now if you're looking to this, then you are having here 0, 1, 1. So you already even number of 1 is there. So that's why you're going to add 0. So that is the 0 I have written here. So if you compare this P4 with that the received bit P4, that it is 1 and it is 0. So that means it's not same, it's different. So that's why P4 is going to be 1. Okay, so because there is an error, it's not same bit. So this is the 1. So this is what I mean. After getting these values that P1 is 0, P2 is 1, P4 is 1. So whatever the values you go, you should need to be considered from bottom to top. So that means it is P4, P2, P1. This is like that. If the result is P4, P2, P1, if it is that all the zeros, if you found, then there is no error actually into the received bits or received data. Okay, if there is 3 zeros, but we can see that there is no 3 zeros. Yes, it is going to become 3 zeros if you are actually working with that the original encoded message, then it is going to become all zeros. So now so it is not zeros. So what we have found for P4, P2, P1, I found 1, 1, 0. So that is we are writing 1, 1, and 0. So you know it that it is 1. If you're converting it with the magical numbers, 8 magical numbers, so that is the 1, 2, 4, right? As because it is 0, so it is going to be 0, and it is going to be 2 and 4. 4 plus 2, it is going to be 6. So that is the receiver understand that bit number 6 has the arrow. So come to this receive bits. So it is 1, 1, 2, 3, 4, 5, and this is the sixth. So that the sixth bit has error. Okay, so it has been found the sixth bit has error. So this is actually showing here 1, 2, 3, 4, 5, 6. This is the same data byte I have written here, so that receiver can see that this is the bits is error. Okay, so these bits can be represented 0 and 1. So as because it is 1, it is an error. So what he is going to be do, he is going to be just put it here the 0. Okay, instead of 1 he is going to be place the 0. So with that he is going to be correct, he will correct that the bits. Okay, so that the code has been corrected. So now again from right to left, so the corrected bit you are going to be placed in the table, the same table that P1, P2, D3, P4, D5, D67. So you can see that 0011 001 0011 001. So now the receiver knows that this is my parity bit, this is my parity bit, and this is my parity bit. He is going to be removed. So it's going to be get the original data now 1001. So you can see that 1001. So this is that the 1001 message actually you have encoded into the sender side. Is it clear?
Sir, why we cross this line P4, P2, and P1?
Again, again.
Why we cross the P4, P2, and P1?
Yeah, because this is the corrected message, right? So this is the corrected message that you have placed on the table, right? So you need to be now get at the original data, right? So that the with that the data you are having the parity bits, so that the parity bits should need to be removed. That is we call the decode, right? So that is the for getting the original message you have to remove these parity bits. These the three parity bits actually you have added with the encoding. So it was your original data. With that you have added that 1001. With that you have added. I mean that you have encoded the data. Okay, you have
Got it,
added the
sir.
parity bits here, right? So that's why it was encoded. I mean with that the three parity bits. So that the three parity bits you should need to be removed. If it is I mean, correctly you found in the receiver side, if you are correctly finding that the bits, then you should need to be removed to get the original message. That the parity bits you must need to be removed. Clear or not?
Yes, sir.
Yeah.
স্যার
So
P4 P2 P1 equals to 110 স্যার এই লাইনটা একটু বলবেন স্যার
this one.
নো স্যার ইয়েলো কালার লাইন স্যার P4
Yeah.
P2 P1 equals to 110 6 bit nong has
Okay.
11
Okay. This
this
one.
line yes sir this line
Yeah. So we see that the result we have found here, right? This is that the result we have found. That I mean, if there is an arrow or if there is no arrow. So first one was no arrow, but later two we have found that the arrow. So when you are actually found these values, then you are going to be considered from that bottom to top. So that means what does it mean? The serial actually that how the parity bits are going to be serially placed from bottom to top. So that bottom one is P4, the next one is P2, then the next one is P1. So that we are writing P4, P2, P1. Okay. So
yes
if
sir
these all the values are zeros, if you're finding that all the values are zeros, okay, then there is not going to be any error. Okay, so that means the receiver has received that the correct bits of data. Understand?
yes
But
sir
we have
clear
not found that all zeros. Yeah, you can try at your home with that the original encoded message. On that time you'll find it out that all of them are coming zero. Okay,
yes sir
so here it is not came that zero, and we know that it will not come because we have actually changed a bit from that the original message. So that's why I mean we have you have done this. That I mean we have written this the P4, P2, P1, and we have put the value accordingly 110. So that 110, and you should need to be convert these binary bits to the decimal. So if you're getting that decimal bit, so you know now that yes, the six number bit has the arrow. So you can actually count that 1, 2, 3, 4, 5, 6. So this is the bit actually receiver understand that there the arrow is. So if it is that one, we can see that the bit number is 1. So the receiver understand that the arrow is here and it is 1. So he is just going to be change it to that the 0. Okay, to make it correct. Understand?
yes sir clear
All right. Is there any other question in that part? In this part? So yes, I mean these are the techniques of that the error correction, error detection, and error correction we are studying. At least I think 10 marks minimum 10 marks portion is going to be there in the final examination, and Hamming code is very important for I mean very important. Actually, all of them are very important. That all the techniques, but Hamming code is actually is very popular. Okay, in that it's a very popular technique for the error detection and correction. So you should need to be actually understand this, because maybe in future higher studies also you need this. Okay. All right. So we have done. As because you're not asking any questions, I'm taking it that actually you have clear about it. So my suggestion is actually practice it. Okay, so you have given here that the two more data bits, so you can do them for not only you are going to be do the Hamming code generation or encoding with these two, but also you can try with that your I mean receiver side, that the error detection and correction you can practice. I think if I practice these three, then I think you are going to be very clear about it. If there is any troubles or any issues, make the note. We are going to be have a consultation hour before the exam, so on that time you can actually ask me to revise it if there is any issues are there. All right.
Yes, sir.
Can you please click on the raise hand? I want to check how many people are listening to us. Not so many actually. I think around 25 people are listening us, and others are actually doing something else. Okay, so I have uh, here I have made a final slide for that, the Hamming code. Actually, what we have done with the Hamming code. So we say that we have done an encoding, error detection, error correction, and decoding for the data 1001. So in the sender side, we have get these 4 bits of data, and we applied here that the Hamming code generation, and we have done that the encoding with that the event parity. So both side is actually decided to go with the event parity, so that this that the encoded message. So you can see here we have sent it to that the next node. So during that the transmission, the original message or bits are actually corrupted. So that is the receiver side has received, we have shown. And then we have, by applying that Hamming code error detection procedures, we have found that yes, the error is in that the 6 bit, the orange one. So we have corrected that bit, and then we have decoded and finally got that the original message. Clear that what we have done that.
Yes, sir.
All right, so we can go to the next. So that is the next one is the cyclic redundancy check. Or you reminder that we are discussing about these methods, the detection methods for parity check we have done. Now we are moving to cyclic redundancy check, and we are having that checksum after that. So that the cyclic redundancy check, there is the another technique for error detection. So it's simply we call it CRC, cyclic redundancy check. In this, usually that the data bits are going to be given to you. That is that you can see here 100 and with that there is going to be give you, might be there is going to be give you a CRC generator. So a code like that, S cube, X square, and 1. So if it is given to you, then actually you should need to be convert it to that the binary bits, and this is going to be the I mean, as because we say that it is the CRC is based on the binary division, so that is going to be used as a divisor. Okay, So how to calculate that? I mean, how to convert it to the binary bits from the CRC generator, that we have to know. So it is very simple. If you are carefully observing, then you do not need. I mean, you are going to be quickly understand it. So you are going to be just formulate it. You are going to be use this formula, that is x0. Then you are having the x1. Then you are having that the x2. Then you are having that the x3. Then you are having that the x4. And this way you are going to be moved to that the x to the power n. So this is that your formula, nothing else than that. So you can check the given CRC generator you are having here. What is that the highest power of the x? That is the x cube. So you have to go 0 to the x cube. This part is not required. Okay. So now you are going to be check that you have given x cube, x2, x1. So you have to start right to left. So it is the one, that is the one for x0. Okay. So that you have written one. And then you can see that next one is my x1, but x1 is absent. There is no x1. So that's why for that we have to give 0. And then yes, x2 is the next, and x2 is here. So that means it is going to be 1. And then we are having the x3. Next is the x3. Yes, x3 is there. So that is going to be 1. So this is going to be that your binary conversion for x cube plus x plus 1, x square plus 1. So you can see that it is 1 1 0 1. Is it clear?
Yes, sir.
Okay, so let's check with that the another example. Say that it is x to the power 4. Then you are having the x to the power 2. Then you are having the, so that this is that plus x to the power 2 and plus 1. So if you convert it to that binary, then you can see that x0 is 0 1. So you're writing 1. Then you can see that next one is x1, but x1 is absent, so it is going to be 0. Then you are having the x2 next. Yes, x2 is there, so that is going to be 1. So you can see that next one is the x cube, but x cube is not there, so that's why this is going to be 0. And the next one is the x4, so x4 is here, so that means it's going to be 1. So this is going to be the conversion to the binary. Is it clear?
Yes, sir.
Very easy, right?
Yes, sir.
Okay, so now what you are going to be do, that the CF from the CRC generator, that the binary conversion you have done here, that you have to count that how many bits you have found here. Look, that we have found here 1 1 1 1. So that means 4. 1 2 3 4. There are total 4 bits we have found here. So whatever that number of bits you are finding here. So if I'm say that number is a, for example, so a minus 1, that is, so you have found the 4, so it is going to be 4 minus 1. So you are getting 3. So that the data bits you are having, with that data bits, that three zeros are going to be added. Is it clear? So you can see that 100 100 and 3 zeros we are adding. 100 100, that is my original data. So 3 zeros I am adding here. Is it clear?
Yes, sir.
Okay, for example, that we have found this as a divisor. Okay, so tell me that how many zeros I am going to be add with the data. If it is found that the binary bits, then how many?
4 0.
4 zeros. Right, very good. So this is the total number of 5. So that is going to be 5 minus 1, that is 4. So the 4 zeros is going to be added on that case. So here we have found the 4. So 4 minus 1, 3. So with that the data bits, the 100 100 100 100, we have added 3 zeros. Okay, so now we are ready to actually do the division. So usually normally that when we are doing that the division, this is the divisor, and this is that the quotient. But the quotient actually we are writing on the top. You can see that it has been given a given here, the quotient. So usually in the normal division, we keep that the quotient here. All right, so we can start it. So we can we have to bring that the divisor here from the left, the 4 bits you are having. So 4 bits. So that is the 11001. So for bringing that in the quotient, we have to place 1. Okay, so you are bringing that here 1101. So you are ready to. So this here we are going to be do the XOR. So that means it's going to be that 1 1 it is going to be 0, 0 0 it is going to be 0, 0 1 it is going to be 1, 1 0 it is going to be 1. So you can check here that 1 1 means here it is 0, and 0 0 means here that, okay, so 0 0 means here 0, 0 1 means 1, and 1 1 means 0. So if the leftmost bit you have found 0, so that is going to be always avoided. Okay, so we are not going to be write that. So now you can see that we are having here the total 3 bits. So we are having in the divisor 4 bits. So you have to bring that the next the 0, one of the 0 from the top. So you are bringing that the 0. So now you are having the 4 bits. So now you want to bring that the divisor. So that's why you are writing 1 into the quotient and you're bringing that 1101. Now do the XOR. 0 1 is 1, 0 0 is 0, 0 1 is 1, and 1 1 means 0. So we say that if leftmost bit we found 0, then we'll skip it. So now you are having that the 3 bits. So that means you have to bring the next 0 from here, and you are bringing brought here. So now again you are going to be bringing this divisor. For that you need to put 1 into the quotient, and then you have brought it that 1101. So now you are ready to do the XOR. 0 1 means 1, 1 0 means 1, 0 1 means 1, and 1 1 means 0. So we say that leftmost 0 it is going to be always avoided. So now you are having the 3 bits, so you have to bring the next zeros. So you are bringing the next zeros. So now you want to bring that the divisor. So for that you have to write 1 in the quotient. You are bringing that 1101. So now to the XOR. 0 1 is 1, 1 0 is 1, 1 1 is 0, and the 1 1 is 0. So we say that if it is coming the leftmost bit 0, then we are going to be avoid it. So now look that the 4 bits you are having here, the leftmost bit is 0, still 0. So if you are finding that it is the leftmost bit is 0, so you have taken this 0, of course, for making it 4. And with that the 4 bits, we see that the leftmost bit is my 0. So if it is 0, the rule is that instead of the divisor, you are going to be take that the 4 bits zeros. So this is actually say that when the leftmost bit of the remainder is 0, we must use 4 zeros instead of the original divisor. So the original divisors are with the four numbers, 4 bits. So that's why 4 zeros. If it is the 5, then it will come with the 5 zeros, something like that. So when you are placing that, if you want to bring that 4 zeros instead of these, then you have to put a 0 here in the quotient. So then only that the 4 zeros will come here. So you are doing the XOR. 0 0 is 0, 1 0 is 1, 1 0 is 1, and 0 0 is 0. So if you found the leftmost 0, that is going to be avoided. Now you have got 1 1 0 that you are having here the 3 bits, so that you have to bring that the 0, that is the last 0 you are bringing here. So now you have to bring that the divisor here, so that you are putting here in the quotient 1. So you bring that 1101. So now that you are going to be do the XOR. 0 1 is 1, 0 0 is 0, 1 1 is 0, and the leftmost 1 1 is 0. So leftmost bit, if it is 0, then we are always avoiding it. So now that this is the reminder you have got, nothing is left. So that means this is the reminder you have got, and this is actually your CRC code. So when you are going to be now saying that the original data, that your original data was 100 and 100. So you can see that 100 and 100. So with that the original data you have added here that the your CRC code, that is 001. Clear?
Yes, sir.
So
Yes, sir.
this has been set to the into the receiver side. So the receiver side has received it. So you can see that it is 100. So 100, 100, and 001. So that is the data plus CRC has been received by the receiver, and the divisor is that one. The receiver is going to be find it out. The divisor is this. So he is going to be do that the division again. So if you are doing the division, same thing, same way you are going to be do it. So if you want to bring that 1101 here, so you have to make write 1 into the quotient. you are going to be do the XOR job. So you are getting 1 1 0 0 0 0 0 1 1 and 1 1 means 0. So the leftmost 0 is going to be always avoided. So you're having the 3 bits here. So you need one more bit. So that's why you are bringing that the 0. Why I need one more bit? Because we are having the 4 bits here and here the remaining is 3. So that's why you have to bring the 0. So now that again you want to bring that your divisor. So you're taking that the 1, writing that the 1 in the quotient and you're bringing that 1 1 0 1, the divisor. So now you can do the XOR job 0 1 1 0 0 0 0 1 1 and 1 1 means 0. So you are going to be leftmost bit if is 0 that we are avoiding. So there are 3 bits now. So we have to bring that 1 0. You are bringing the 0. So now you are ready to take the divisor here. So for that you are writing 1 into the quotient and you are writing here that 1 1 0 1 is the divisor. So now you want to do the XOR 0 1 1 1 0 1 0 1 1 and 1 1 0. So we said leftmost bit if I found that 0 that is going to be avoided. So we are having the 3 bits. So now we have to bring that the next zeros. So we are bringing that the next zeros here. So now we are ready to take the divisors here 1 1 0 1. So for that actually we have to write 1 here on the quotient. So you are bringing that 1 1 0 1. So now do the XOR 0 1 1 1 0 1 1 1 0 and 1 1 0. So if you're doing that, the leftmost bit if found 0 0, so it's going to be avoided. So now you're having the 3 bits. So you have to bring the next zeros here. So you are bringing the next 0 here. So now you can see that out of the 4 bits, the leftmost bit is 0 0. So that means you need to be bring instead of the divisor, you need to bring that the 4 zeros here. So to do that, you are writing that the quotient on you are writing 0. So it is 4 zeros are coming here. So now you're going to be to the XOR 0 0 0 0 1 0 1 1 0 1 and 0 0 0. So we said that if the leftmost bit is 0 we found, then it is going to be removed or avoided. So now you're having the 3 values, 3 bits. You're having the 3 bits. So now you have to bring it. This is actually 1. So you are bringing that the 1. So now you are getting that. You want to bring that the divisor. So for writing that, you have to put the 1 here. So you are bringing that 1 1 0 1. So now you are going to be do that the XOR. So you are finding that 1 1 0 0 0 0 1 1 0 and 1 1 0. So leftmost bit it is going to be always avoided. So that is you are finding that all zeros here. So that means there is no error. If you find here that all zeros, that means there is no error that what the receiver has set. But if it is if you are finding here any combination with that 0 or 1 or 1 on the or 1 1 1, then it is going to be that the arrow. So if it is no arrow, that means the CRC codes are going to be removed from that the received data, and then it's going to be get that the original data. And if it is an arrow, then actually it is going to be simply reject the data. The receiver will reject the data. Clear?
Sir, since first one is 001, mix of zeros and ones, this was an error, sir. Right, sir?
Yeah, this one here, if you're getting that anything then that does 000, if you're getting here, then it is going to be in arrow. Understand?
Yes. Yes.
Right. For example, that if it is receiving here, for example, that last one, for example, is 0. Okay, so look that you are bringing here 0. Okay, so now you are having here that if you're counting here, you're getting 001, isn't it or not?
Yes.
That
Yes,
means
sir.
replace it as the arrow. Clear?
Yes, sir.
It's easy, right? CRC is easy. It's not tough. Agreed or disagreed?
Yes, sir.
Agreed, sir.
Mm. Okay, so the last thing here we are having, that is the checksum. So you already know that the checksum, because we have done it into that the UDP protocol in the transport layer. So it is again it is having here into that into the data link layer, and procedure is same. So you can see that here this is my sender and this is my receiver. So what is he going to be do? So he's going to be add the checksum field is to get that the checksums the data bits or bytes are going to be added, so that the sum you will get from that the sum you are going to be make the complement and you're going to be get the checksum value. So that is going to be added here, and it is going to be sent here. And now you have got that the different number of bytes, including the checksum, that you should need to be add. So you know that adding procedure. So if first two bits bytes you're going to be add with the result, you are going to be add the checksum, and that if there is another bits you are having, that is going to be added. So that the sum you have got here, that the sum you need to be make the complement. So that the complement you have got here, if it is all zeros, if there is no error. If there is mixed or the all one, that is going to be the error. Okay, so he said that the result is zero, keep, otherwise discard. So this is what it said, that there are some methods that how you are going to be create the checksum in the sender side. Okay, so we have already learned it, so I don't want to go for that. You can see here that we are having an example from the sender side how the checksum bits are going to be generated. So these are your original bytes, 2 bytes have been given here. So when you add these 2 bytes, you are getting that the sum. So after getting the sum, that you're making it one's complement. Okay, that if you're making a one's complement, you can check that zero means zero and it is getting one. So as because it is one, it is zero, zero, one. So it is zero, that's why one, zero, that's why one. It is one, that's why zero, one, zero, one, zero. So that is the one's complement, and that the one's complement value is going to be a checksum. So when the sender is going to be send that the 2 bytes of data, so that with that the 2 bytes of data, it is going to be add that the checksum value. So now the receiver side has received it. Okay, so what receiver side is received it? So 3 bytes, including the checksum. So now he is going to be add these one and this one first. So this is actually here written 1 1 0 1 0 1 0 1 0 1 0 1 0 1. The next one is that 0 0 1 1 0 0 1 1 1 0 0 1 1 0 0 1. So this is two things, that 2 bytes you are going to be add to the addition, and with that the addition you are going to be add the checksum, this third one. So when you are going to be do that, then actually you are going to be get the sum, and then you have to make it one's complement, and if you can see that it is all zeros. So that means the data it has been received from that the sender, the receiver has found that there is no error. Clear?
Yes, sir.
Okay, so that this is also the another example has been given. So this also, I mean, this is similar like that in the UDP that we have done. Okay, so here actually you can see that we are having the 450. So here we know that we are allowed to take here the 16 bits, and this is also the 16 bit. So you can see that we have taken that 0, 5 and 0 that we have converted to here. So that is going to be converted into the binary, and then you're taking the 28, so that is going to be converted to the binary 16 bits. Okay, so do you understand this? So this is that the 4 bit, this is that the 4 bit, that is that the 8 bit, and this is that the 8 bits are 0, and it is you are having the 16 bit. So that is what it is your 32. So you can check that how it has been done. So the 8 bits you are having, this is the 8 zeros, and you're having that the 5. So you can see that it is 5 0 1 0 1. So 1 2 4. So 4 plus 1 5, and the next one is 4. The value is 4. So that is here 0 0 1 0. So that means here 1 2 4. Is it clear?
Yes, sir.
Yeah, right. So now you are going for that 28. So these all are actually converted, that the data we are having here. And yes, we know that we have to do that the addition 2 by 2. So I mean, this is that the 2 bytes we are going to be added, and after that the result we will get, if we are getting a carry, that the carry is going to be added with the summation, your addition, I mean with the result. And after that we are going to be with that the resultant, we are going to be add this, and again we are going to be, after the addition, if I'm getting carry, that is going to be added. If there is no carry, then it's going to be with the resultant, we are going to be add this way, it is going to be added one after another. and when you are going to be do that the addition, so you are going to be get the complete total sum. So that the total sum you have found here, so that you're going to be do the ones complement to get the checksum. So you can see that 0 means 1, triple 1, so triple 0, so 0 1 0 1 1 0 0 1. So this is 0, this is 1. So one's complement of 0 is 1, one's complement of 1 is 0 0 1 1 0 1 0 1 0 0 1. So this is that the checksum value that you have got. So while the sender is going to be saying that the data, so the checksum value is going to be added here in this field, so 16 bits field. Okay, so when it is going to be receiver is going to be receive this, so receiver is going to be do the same job. Okay, he is going to be add everything including the checksum, and after that the sum result he's going to be get that he's going to be make that the ones complement of it. And if he's doing that the ones complement, if he is getting that the 0, that means all zeros. If it is getting that, that means the receiver has received it correctly. If he finds that any combination other than that the zeros, then it's going to be understand there is an arrow. So if there is an arrow, this is going to be discarded. Clear? Is it clear?
Yes, sir.
Yes, sir.
Yeah. So it says a completely silence in that the classroom. Okay, nobody is talking. So I have some doubt that if people are listening the lectures properly or not. We are trying to understanding them or not. So you should need to be make sure that you are listening the lectures carefully. Your exams are very nearby, so you should also make sure that you're studying properly. Understand?
Okay, sir.
Yes, sir.
Okay. So do you have any questions? So we have actually done that the error detection and correction part. Okay. So do you have any questions into that error detection and correction part?
স্যার আমাদের এখানে যে এরর ডিটেকশনের পদ্ধতিটা আর আগে যেটা বলছিলাম স্যার সেমই তো, তাই না?
Yeah, the checksum. You're talking about the checksum.
ইয়েস স্যার।
Some you have done for that UDP, TCP, and the data link clear is same. No difference.
স্যার তাহলে মানে আমাদের সবার শেষে যে রেজাল্ট আসবে এটা সবগুলা জিরো হইতে হবে। জিরো ছাড়া যদি সবগুলা ওয়ান হয় বা জিরো আর ওয়ানের মিক্স হয় তাহলে এরর থাকবে, তাই না স্যার?
Yes, exactly.
ওকে স্যার।
Okay, so we have any other questions into this part? You should need to be actually practice this all of the techniques or methods that actually we have discussed for the error detection and correction. One I already said that 10 marks question will come in the final definitely from this part. 100% it will come. Okay, so you have to make sure that this is the error detection and correction part from this data link clear. You are practicing at your home, and you are very much clear about the concepts that actually we have discussed in the class. If you have any confusion, keep the notes with you in the the consultation day. We are going to be able to revise them. Okay.
ইয়েস স্যার।
Yes,
স্যার
sir.
আমাদের প্রজেক্টে স্যার অনেকের টপিক তো সেম হইতে পারে বা টপিক এসব সম্পর্কে যদি একটু চেক করে দিতেন স্যার আমাদের। কালকেই তো মনে হয় করবে, তাই না স্যার?
So yeah, that is going to be clear on tomorrow. Okay, that on tomorrow you are going to be know that which people is doing what. Okay, which group is doing which topic. I don't think so that it is going to be same.